Question 1 says, the table below shows the number of pupils in a class who are right-handed and left-handed. One boy and one girl are selected at random. Calculate the probability that both pupils are left-handed. Okay, first of all, for the boys, we've got a total of 11. For the girls, we've got a total of 12. And we want to have both pupils are left-handed. So probability both. That means you've got a boy is left-handed and a girl. So it's multiplied. When you say and, you multiply, and also a girl is left-handed. So the probability a boy is left-handed, you've got 3 out of 11, so it's 3 over 11. And then times, probably a girl is left-handed, it's 7 out of 12. And then you just multiply that and see what you get. So putting 3 over 11 times 7 over 12 into your calculator just comes out as 7 over 44. Question 2 says 10 students had a part-time job during the summer. Jack recorded the number of hours they worked each. Jack recorded the number of hours they worked each week and the corresponding amounts they were paid each week. The results are shown in the table below. So you've got hours and the amount paid, and then we're going to have to rank these. So we're going to do the rank for the hours. So I'm going to do this in ascending order, and if you do it in ascending order for the hours, you've got to also do it in ascending order for the amount paid. So the smallest thing I can see here is the 10. So I've got my 10 is number 1. Then I've got the next smallest is a 12. It's going to be number 2. The next smallest is a 15. It's going to be number 3. The next smallest is going to be the 16. It's going to be number 4. The next smallest is going to be the 24. Number 5. Then we've got 28. Number 6. Then we've got 32, which is number 7. Then 35. Number 8. And then 40 is number 9, and our last one then is 10. Remember, we had 10 students, so it makes sense for me to go from 1 to 10. Okay, the next one then is where I would expect to have tied ranks somewhere. So my first one, my smallest one here is 120 as far as I can see, so it's number 1. And then, be very careful here, we've got 180, 2 180s. So they would have been the second and the third rank. So 2 plus 3 is 5, and divided by 2 is 2.5. So they both get ranked as 2.5. Okay, now we're on to our next one. So remember, we've just done, that really was the first, the second, the third. So this is us looking at the fourth person. So this next rank should be the fourth one if they're on their own. So we've got, what have we got? What's our next lowest one? 260. I don't see anything lower than 260. So that would have been the fourth person. So we're now on to the fifth person, which is going to be 320 is my fifth person. My sixth person then would be 340. My seventh person then would be, oh, I almost missed that one, 350. My eighth person then would be my 360. My ninth person would be 430. And my 10th person then is 460. Okay, if we just have a look at these, we can see there does seem to be some sort of correlation. The smaller numbers, the bigger numbers there, 9 and 10, they're fairly close. 5 and 5, they're spot on. 1 and 3, still fairly close numbers. 7 and 8, fairly close. 1 and 2.5, fairly close. 10 and 9, fairly close. 4 and 4, perfect. 6 and 7, fairly good. 2 and 2.5, almost perfect. 8 and 6 are fairly close. So I would expect there to be a strong correlation. So just to have me an idea in my head of what's going on. Now, Spearman's rank is way back at the start here in our formula booklet. We had our Spearman's rank. Spearman's coefficient of rank correlation is given by R is equal to 1 minus 6 times sigma d squared, where d is the difference between the two things, and n is your number of variables. So let's go back to our question. We've got to find our d, and I like to just put in a d column and then a d squared, and I think that's really what they intend us to do. So this is the difference between them. So 9 minus 10 is minus 1. Square that, you'll get 1. 5 minus 5 is 0. Square that, you'll get 0. 3 minus 1 is 2. Square that, you'll get 4. 7 minus 8 is minus 1. Square that, you'll get 1. And then 1 minus 2.5 is minus 1.5. And then if you square that, you will get, and it's going to be 2.25. And then 10 minus 9 is 1, square that you get 1. 4 minus 4 is 0, square that you get 0. 6 minus 7 is minus 1, square that you get 1. 2 minus 0.5 is minus 0.5, square that you get 0.25. 8 minus 6 is 2, square that you'll get 4. So sigma d squared is going to be those added up. So 1 plus 0 plus 4 plus 1 plus 2.25 plus 1 plus 0 plus 1 plus 0.25 plus 4, which works out to be 14.5. Okay, and Spearman's rank correlation coefficient, which I've forgotten already. Here we are, here we have it here. R is equal to 1 minus 6 sigma d squared over r upon r n squared, sorry, n over n upon n squared minus 1. So let's write that down. And then we just fill that in. So that's 1 minus 6 times my d squared, sigma d squared, which is 14.5. My n was 10, and then 10 squared minus 1. And then just put that into your calculator. No more working out is needed. I'll just put that in and see what I get. So I'm just doing that in one go calculator. 1 minus, and fraction button, the top line is 6 times 14.5. Bottom line is going to be 10 upon 10 squared and minus 1. Close your bracket, press equals. I have got point, and it comes out as, the pen's not working here, as 0.9121212 and so on. And then you have to give your answer to whatever the degree of accuracy it is that says on the front of the paper, which I should have read. Where rounding is necessary, give answers correct at 2 decimal places. So here we go. Let's put this back to 2 decimal places, do this properly. So 2 decimal places is going to be 0.901, and that's to 2 decimal places. Okay. Right. Interpret your answers. So there's a strong correlation. Correlation between whatever the two variables were, and the two variables were the hours worked and the amount paid. So of course there's going to be really between the hours worked and amount paid. Okay, calculate the mean hours worked and the mean amount paid. So we're going to have to go back to our table and look at this again. So what I would do here is I'd just do my sigma equals and sigma equals. So I'm just working these out. So 40 plus 24 plus 15 plus 32 plus 10 plus 48 plus 16 plus 28 plus 12 plus 35. So I've worked out those totals. So that's going to be 260 for that one. And the next one then is going to be 460 plus 320 plus 120 plus 360 plus 180 plus 430 plus 260 plus 350 plus 180 plus 340, which is bang on 3,000. So we can go down and do that. So the hours worked was 260 total for all the hours worked. The total amount paid was 3,000. So calculate the mean hours worked. So the mean hours is equal to 260. And remember, there are 10 people, which is going to be 26 hours. And then the mean amount paid is just going to be, it was 3,000 divided by 10, which is going to be then £300. So 26 hours and £300. Okay, the next part of this question says the data from the table are plotted on the graph below. What you have to do is draw your line of best fit. So what you've got to do is plot your point, which is your x bar, y bar point, and we know our x bar y bar point is 26,300. So this is your average point that it has to go through. So apologies for this being so wonky here, but 26,300 is going to be, I'll zoom in on this a wee bit. So 26,300, if I just use this so you can see it's going up, there's 25, 26, 27, 28, 29, 30. So 26 is going to be here, and 300, so I'm going to be doing my wee dot bang on here. Okay, so that is the point about which my line should be. So I'm going to pause the video, I'm going to have a wee go at doing this. So my line of best fit has to go through this point, and also, so it's pivoted on this point, and I'm going to try and get as many things above or below, same number of things above or below. Okay, I've drawn my line of best fit like this, so I've got 1, 2, 3, 4, 5 points above, and this one is actually on it, and I've got 1, 2, 3, 4 below, but I've also put my point through my origin. The reason I've done this is because of what it is. It's if your hours paid, if your amount paid and your hours worked, so it's going through the origin, they may not like this. They may want you to have not put it through that and done maybe something like this, but I've just used a wee bit of common sense really to think about what we're actually dealing with, but they may not like that, so just check a mark, see when it comes out properly, and see what they're going for. But how you do this, we'll do this the same way anyway, how you would go about this long way. And I'm going to use show all the working out, which I don't really need to do for this one. I'm going to use this point and also my min point to work out my gradients. The next thing is we've got to draw your equation. If you're draw your line of best fit. Done. Next part of the question asks you to find the equation of your line. So you draw a triangle, and I'm going to use this point, which is 0, 0, and I'm going to use this point then, which we knew to be 26,300. So there's 2 points. So I picked nice points which I knew, and I'm going to work out the equation of this line of best fit using these 2 points. So draw your line of best fit in the graph. On that, we have to determine the equation of the line of best fit. So our 2 points are 0, 0 and 26,300. I can easily, line of best fit, straight line, y equals mx plus c. I can easily see my intercept is 0, 0, but just in case they want you to do it a different way, or it was a question where you couldn't go through the origin, I'm going to show you the way how you would do it just by subbing in a point. I'll sub in this point into my equation. But my gradient, my m, is my vertical distance over the horizontal distance, so 300 minus 0 over 26 minus 0, which in this case is just 300 over 26. So 300 divided by 26, which works out to be 11 which is equal to 11.54 to 2 decimal places. I'll not put it in that way for a wee second, but then our y then is equal to, and it was 300 over 26 x plus c, and that means sub in the point 0, 0, so just I'm going through this just to show you the steps. So 0 is equal to 300 over 26 times 0 plus c, and that means 0 is equal to 0 plus c, which implies then that c is equal to 0. So it tells you then your equation is y is equal to 300 over 26x, which we had said a wee second ago was 11.54x. Paul recorded question 3. Paul recorded his golf scores over the course of a year. His results were summarised in the table below. So we've got the scores of frequencies, and it says calculate an estimate of the mean. So I'm going to find my midpoint x first of all. I'll then have an fx column, and we'll be able to go from this. So the midpoint is just the add your 65 and your 67, divide by 2 is going to give you 66, add 68 and 70, and divide by 2 and see what we're going to get. Okay, so they're all filled in. The next column, the fx then, is just your f column times your x column. So the first one is 4 times 66, which is 264. The next one's 12 times 69, which is 828. 24 times 72, which is 1,728. 32 times 75, which is 2,400. 6 times 78, which is 468. 2 times 81, which is 162. So your total, this is your sigma f. We need to find our sigma fx. So your total of your frequencies, your f column, is 4 plus 12 plus 24 plus 32 plus 6 plus 2, which is 80. Next one, your fx column is 264 plus 828 plus 1,724 plus 2,400 plus 468 plus 162. Press equals is 5850. And then your mean x bar then is equal to 5850 divided by 80. And when I have done that, I have got 73.125, which is equal to 73.13, and again that's 2 decimal places. What would let's just mark the score. Okay, it's only an estimate because you had to. Why is this answer for the mean only an estimate? You had to use the midpoints. Okay, so you didn't have the raw data, you didn't have all of the data, you had to use the midpoints. So for example here in the 65 to 67, there's 4 people. We do not know what they've actually scored. We know they scored somewhere in this range, and we've made an assumption that they've all scored 66, which may be true, but also it's probably more likely it's not true. So some of them, all 4 potentially have scored 65. Some of them maybe have scored 65, some scored 66, some scored 67. All of them maybe have scored 67. We do not know, so we're having to guess or estimate that everyone in this class interval scores 66. Likewise, everyone in this interval scores 69, and so on. Okay, next thing is calculate an estimate for the standard deviations of the scores. I'll clearly show all your steps. First of all, we'll write down a formula for the standard deviation. So we just flick back to the start here. You can see your formula for the standard deviation is square root of sigma fx squared over sigma f and minus your x bar squared. Okay, so we've got sigma f, we've got our x bar worked out. We need to have a sigma fx squared column, so then we can total them up. So we'll add that in, sigma fx squared or fx squared column. So where did we go to? We're here. We're going to add in an fx squared column. So this is going to be, and you're going to expect very big numbers here. So how you get this, I'll just show you the working out for the first one. It's your f times your x value, which was 66, and it's being squared. So whatever, so 4 times your 66, and then that gets squared, and these are very big, and you should expect these to be big. 17424. The next one again, it's going to be 12 times 69 squared. So 12 times 69 squared, and that is 57132. Next one's going to be 24 times 72 squared. Again, very big. 124,416. And the next one's going to be 32 times 75 squared, which is going to be 180,000. Next one could be 6 times 78 squared, which is going to be 36504. And next one's going to be 2 times 81 squared, which is going to be 13122. So sigma fx squared, when you work that out, when you total those all up, so 17, and this is where people make mistakes, 17424 plus 57132 plus 124416 plus 180,000 plus 36504 plus 13122 is, and that totals up to be 428,598. and then we can put that in. So our standard deviation was equal to the square root, I'll write that formula again, sigma fx squared over sigma f minus your mean squared. So let's just get all that fired in now. So that's going to be 428598. Sigma f, I've forgotten already, sigma f was 80. And then minus your mean. I think I had an exact value of my mean, 73.125, and it was getting squared. Just check that. Yep. Okay, fire that into your calculator and see what you get. So the square root of fraction button 428598 over 80 minus, and then what was that, bracket 73.125, close your bracket squared, and then press equals, and you should get to two decimal places 3.20 to two decimal places. It was 3.1952. So that's two decimals of 3.20, and you need that 0 in get your full marks. Okay, question 4 says complete Pascal's triangle in the grid below. So this one here and this one add together to give the number below, so that's 2. And then you've got 1s along the outside. And then this 1 and this 2 add together to give you 3. Likewise, this 2 and this 1 add together to give you 3. So the next row, it's going to be 3 and 3. Then this 1 and 3 add together to give 4. 3 and 3 add together to give 6. And 3 and 1 add together to give you 4. Okay, next one says, hence write down an expansion of p plus q to the power of 4. Now this tells you how we expand this thing. So 1 is the coefficient of the p to the power of 4 term. And then 4 is the coefficient of the next term, and it's going to be p to the power of 3. So as the p reduces, the q goes up by 1, so it goes up to q to the power of 1, which is just q. And the next term is going to be 6. The p reduces, so it's down to p squared. The q goes up by 1, so it's up to p squared. Next one is 4. The p reduces, it's down to 1, so that's just p to the power of 1, or just p. And the q goes up, p cubed. And the last one is 1 times p to the power of 4. Charlie goes into a room where there are 4 windows. Each window is either open or closed. The probability the window is open is 0.7. And it says find the probability that there are exactly 3 windows closed. Okay, so I'm going to say P is equal to the probability that something is open. And we have got then, we want to have 3 windows open, and that was equal probability that something is open is 0.7. Q then is the probability that something is closed, the window is closed, which is going to be 0.3. So there are 4 windows open. We want to have probability that you have 3 things, so 3 things closed. So we're looking for, if we go back to this, we want 3 closed, exactly 3 closed, so we want the power of this thing to be 3. So q to the power of 3, so it's going to be this one we're looking for, so it's 4p times q cubed. 4p times q cubed, which is going to be 4 times brackets 0.7, that was your p, times your 0.3 to the power of 3. And you just fire that into your calculator and see what you get. So it's going to be 4 times brackets 0.7, close your brackets, and then times brackets 0.3, close your brackets, and that one is cubed. Press equals. It comes out on my calculator as 2500. That's perfect. And then 3 sig figs as it gives you here. That's what you get. But it's 2 decimal places you want to go and give it to. So really that's what it is, to 2 decimal places. So that's what we're looking for then as our answer, we assume. Okay. Find the probability at least 2 windows are closed. So P was the probability that something was probability that something was open. So So it's 0.7. Q is 0.3. We want at least 2 are closed. So at least 2 are closed. Really that means you want probability that x is greater than or equal to 2, which means probability x equals 2, x equals 3, and so on. But an easier way of doing it is probability x is greater than or equal to 2 is 1 minus probability there's none closed, and also that there's just 1 closed. So I'm just going to write that out as 1 minus, and I want them to be, sorry, what were the probabilities here? 0.7 was open. So if there's at least 2 closed, that means they're all closed. So I want the Q to be the power of 4. And I also then want that 4 times P Q cubed. And then we'll just work those out again. So that's going to be 1 minus, and that was 0.3 to the power of 4, all closed, and then 4 times 0.7 times the 0.3 to the power of 3. I think we just did that one. So that's going to be 1 minus, and we'll just put these in, get exact values. So brackets 0.3, close your bracket, to the power of 4. And that works out to be, on your calculator, 0.0081, and minus this one. What was this one? Is a good decimal, 0.075, 0.0756. And then if we do that one out, you're going to have bear with me here, minus 0.0756 plus your 1, and that works out to be 0.9163. So the 2 decimal places is 0.92 to 2 decimal places. Alice took 9 written tests and 5 practical tests in music. The mean mark of her 9 tests was 69. The mean mark of her 5 practical tests was 83. So calculate the mean marks of all 14 tests. I'm going to work out first of all the total for the 9 tests. So it's going to be 9 times 69. So whatever that works out to be, 9 times 69 is going to be 626. The total for the 5 tests, the 5, whatever they were, the practical tests, is going to be equal to 5 times 83. Whatever that works out to be, 5 times 83, 415. So the total overall, so the total, this is the total for all 14, is going to be 415 plus the 621, which works out to be 1036. So the mean for all 14 is going to be 1036 divided by 14, which works out very nicely to be 74. Okay, it says the standard deviation of our 9 tests was 15.4. The standard deviation of our 5 tests was 7.8. Calculate the standard deviation for all 14. Right, I'm going to write down my formula for standard deviation again. Standard deviation is equal to the square root of sigma x squared over n minus your mean squared. Okay, so I need to find sigma x squared. So I need to find that for my, first of all, for the first lot of them, and then for the next lot as well. So for the 9 tests, your standard deviation is 15.4, and it works out to be sigma x squared over n, and n is 9 because there's 9 of them, minus my mean. And what was my mean for my 9 tests? It tells you the mean for the 9 tests was 69. So what I'm trying to do here, I forgot to say that, was I'm trying to work back to get what my sigma x is for these ones. So first thing I'm going to do is square that 15.4. So 15.4 squared, that works out to be 237.16. And that equals sigma x squared over 9 minus 69 squared. And then that's 237.16 plus 69 squared is equal to sigma x squared over 9. and then multiply across. You've got the 237.16 plus then 69 squared, press equals, and then multiply that by 9. I have got my sigma x squared works out to be 44983.44. So that's for the 9 tests we've done. Okay, for the, was it 5 tests? The practical tests, I think they were. Your standard deviation was 7.4. So it wasn't 7.4 at all, 7.8. It was 7.8. So 7.8 is equal to, for it was sigma x squared over 5 minus the mean. And the mean for the 5 tests, let's go back and find out the mean for the 5 tests was 83. So minus 83, and that was squared. So let's just sort that out by squaring the 7.8, square 7.8, and you get 60.84 is equal to sigma x squared over 5 minus 83 squared. And that means 60.84 plus the 83 squared is equal to your sigma x squared over 5, and then multiply across that 5 and you'll find out what your sigma x squared is. So you've got your 60.84 plus 83 squared, press equals, and then multiply by 5. I have got, that is 34749.2. Okay, now I've got this value for sigma x squared, that was for the 5 tests. I have this value for the sigma x squared for the 9 tests, so I can combine them together and put them into this for my 9 tests. And I already know what my combined mean was as well. Earlier on, we'd worked that out. So we'll put all of that information back in. So this is for all 14. Your standard deviation is equal to, it's the square root of, and it's going to be 44983.44 plus, what was my other one? It was 34749.2. 34749.2. That's all divided by 14. Remember, we had 14 values. I didn't give myself enough room here. And then we're taking away our mean, our new mean squared. I'll put that in brackets, just keep it safe. Our new mean squared, and our new mean we worked out was nice. It was 74. So minus 74, and that is being squared. So just a calculator exercise to do that. Apologies for the mess. So square root of, and then fraction button. First of all, 44983.44 plus 34749.2. I'm just going to check that answer. That number's right. 34749.2. Yep, that was all over 14. Then you were taking away your 74 squared. Press equals, and I have got 14.81, and that was the 2 decimal places. Let's have a look at what they had before. Standard deviation for all 9 was 15.4. Standard deviation for the 5 is 7.8. So you would expect the standard deviation to be something around this. 14.81 makes sense anyway. Okay. Question 6 says, students at a school were asked which drinks they drink regularly. 88 drink cola, 65 drink orange, and 7% drink neither cola nor orange. So we've got 7% is in here. They're outside the 2 circles. And then using the diagram below or otherwise, find the percentage of students who drink both cola and orange. I wouldn't really use this diagram, to be honest. I would write down, we've got probability that you drink cola union orange is going to be 1 minus 0.07, so it's going to be 0.93. That's what we know. We also know that the probability that somebody drinks cola is, what was it there, 0.88. Somebody drinks orange is going to be 0.65. And I would use the formula for the union of C union O. So I'm going to say probability C union O is equal to my probability of C plus my probability of O minus the intersection C intersect O. and fill in what you know. You know 0.93 for this one. This is 0.88. This is 0.65, and this is probability C intersect O. Wee bit of rearranging. Probability of C intersect O can come over to the right hand side. You can have 0.88 plus 0.65 minus 0.93, and hopefully this gives us a sensible answer. So let's just put that in the calculator. 0.88 plus 0.65 minus 0.93, press equals. I have got a very nice answer. I've got 0.6. So as a percentage, 0.6 as a percentage is 60%. Find the probability the student selected at random does not drink orange given that they drink cola. Okay, so good time to go back and sort of fill our table in a wee bit better, our Venn diagram. So you can see I've filled this in. We had 60% in the middle. So 88 was the percentage who drank cola, and then 65 was the percentage who drank orange. So 60 plus 5 gives you the 65. 60 plus 28 gives you the 88. So that's filled in everything we need. Right, let's read the question again. Find the probability that a student selected at random does not drink orange given that they drink cola. So out of the people who drink cola, how many do not drink orange? So we have got just this bit basically we're looking at. I'll just shade this one in. That's what we're looking for in yellow. We're looking for that bit, but out of this whole bit here. So it's that's really what we're looking for here. So we're looking for the 28 out of the whole circle. So a 28 out of 88 is what we're looking for here. So let's write that in. 28 out of 88, and that's then 14 out of 44, which cancels down to be 7 over 22. And that's a better answer, but what they wanted to 2dp, so let's just give them that. So 7 divided by 22 to 2dp's is going to be 0.32 to 2 decimal places. But if we need this later on, use 7 over 22. Two students are selected at random. Find probably that one of them drinks cola only and the other one drinks orange only. Give your answer to 3 decimal places. Okay, what we're finding here, we're finding the probability that somebody drinks C only and the other one, and the other one drinks orange only. So that's one way it works. So, or you get it the other way whenever the first one drinks orange only and the second one drinks cola only. So the probability of drinking cola only, that was 28% of people, so it's 0.28. Orange only people were 0.05. And then again, orange only was 0.05. Cola only was 0.28. And then if you do that out, that's going to give you 7 over 500. And that's also going to give you 7 over 500, which gives you, work that out, it's going to be 7 over 250. And that works out as 0.028 to 3 decimal places. And that's what they'd asked you for in this question. Okay, question 7, which is the last question on the exam, says a teacher recorded the times taken to complete a cross-country race by year 12 pupils. The times were normally distributed with a mean of 46, so your mu is equal to 46, and standard deviation of 8. Find the probability that pupil chosen at random took less than 60 minutes. So we're looking for probability x is less than 60. First thing you've got to do is convert that to a z-score. So z is equal to x minus mu over sigma. So z is equal to, our x value was 60, minus our mu, which is 46, over sigma, which is 8. So that gets you a z-score of 1.75. So what your question now becomes is probably that z is less than 1.75. So we'll go back and look at our tables for this. So here we are on our tables, and z is less than 1.75. You go down to 1.7, and then you need to go to the 5, so go to that column here, and there we are. So it's 0.9599. So that's what we're looking for. We'll go zoom back to our answer. Where are we? So there we are. It is equal to 0.9599. Okay, next one, same idea in the next one. Find the probability that a pupil chosen at random took less than 34 minutes. So you're looking for x is less than 34. Convert again, so z is equal to 34 minus your mean, which was 46, over your sigma, which is 8, so z is equal to minus 1.5. So you're looking in this question for z is less than minus 1.5. Right, I like to draw a wee diagram for these ones. I find it a wee bit confusing without a diagram. So there's my bell-shaped curved, and minus 1.5 would be over here, and it's that shaded area we're looking for. So that is the same as flipping that round, and it's the same as this shaded area when you've got 1.5 here. So this shaded area is equal to 1 minus, so probably that z is less than 1.5. So go back to your tables and find 1.5, and it's going to give you on the tables 0.9332, sorry, which gives you 0.0668. Okay, so 0.0668. Very last part of this question, find the probability that a pupil chosen at random took less than 34 minutes to complete the race, given that he took less than 60. So you're looking for the probability they took less than 34, given that they took less than 66. Right, this is from your formula. Probability of A given B is equal to probability of A and B divided by your probability of B. So in this case, that's a probability that it's less than 34 and it's less than 66, and divided by the probability that it is less than 66. Okay, now let's think about this one. If I told you I am less than 66 years old, and I also told you I am less than 34 years old, then the less than 34 years old would override the less than 66. So this thing, probably less than 34 and less than 66, that really just means the probability that something is less than 34. So that's where your top line becomes, and you've got both of those things. That's where you worked out in the two previous parts. So it's 0.0668 divided by whatever we got in our part 1, which was 0.9599. And if you do that to 4 decimal places, it's 0.0696 to 4 decimal places. And that is us done.